For section 3.3, we're moving into solving systems of linear inequalities. And all that's going to change is instead of an equal sign and just having a line, two lines and trying to figure out the point at which they cross, we are going to have two different lines and then we're going to have shadings. So remember, is less than, is greater than, shading above and below the lines. And we are looking for where the shading overlaps, and there's an infinite set of points that are in that fall into that overlapping shading region, and those are all of the answers. So we can't possibly list them, but we can show them on a graph. So for example 1, we are graphing this system here. Y is less than or equal to negative 2x plus 4. So it's solved for y, so that's our first step. We want to make sure that's taken care of. And then we're just going to graph. So just like before, we're going to graph the y-intercept first. So remember mx plus b. B is our y-intercept. So this one has a dot at positive 4. And our slope is negative 2. So what that means is we're going to go down 2 and right 1. Because if we were to write negative 2 as a fraction, it would look like that. So that means we'd go down 2 and right 1. And then if I do that a couple of more times just to get a few more points so that I can try to make the best straight line as possible. Down 2 over 1, and then I can go up 2 and left 1 there. And then I can attempt to draw a line. Now, looking at this inequality symbol over here, it's underlined, so that means we're going to take a solid line through those points. And y is less than, that's the is less than symbol, so we're going to shade this whole area here. Then for the next inequality, we have y is greater than x minus 3. Minus 3, or negative 3, is our y-intercept. So we're going to put a dot at negative 3. And 1 is the number in front of x, so that's our slope. So we're going to go up 1 over 1. So I'm just going to make all the dots I can, just so it's easier to draw that line. But I don't want to make a solid line because that inequality symbol is not underlined. So this gets a dashed line. And I don't know. So that means that our solutions are not on that line. Y is greater than, so we're going to shade above that line. Remember, trying to decide whether you're above or below is thinking about sitting on the line. So if you were to sit on the line, what side would you sit on? That's the top. And then our job here is to show where the two lines overlap. So that area needs to be darkened in. So our solutions are all of that area there in black. So we're going to do one more. This one is y is greater than or equal to 3/2 x plus 2. So our y-intercept is a positive 2. And our slope is 3/2. So up 3 and over 2. And I can also go down 3 and back 2. I'm going to do that a couple of times. And this one is underlined, so I can make it a solid line. Yeah, it's close. And greater than, so greater than is here. Then x is less than 3. So it doesn't start with a y, it starts with an x. So that means we have to start on the x-axis at positive 3. So here, and it's just x and 3. So this means it's going to be a straight up and down line on 3. And it's not underlined. So this is a dotted line. Our solution is not part of that line, so none of the points on that line will work. And then x is less than. So less than 3 is all over here. And then we want to darken in the area where they overlap. So that would be right here. Now we have a word problem. And it says a polar expedition is 240 miles away from base camp, and a snowstorm is predicted to reach the area in 48 hours. The expedition will travel as far as possible by boat and then walk the remaining distance to camp before the storm hits. The explorers can navigate the boat through the ice at a rate of 12 miles per hour or walk with the equipment at a rate of 3 miles per hour. Write and graph a system of inequalities that can be used to determine how long the explorers may travel by foot or by boat to reach the base camp before the storm. So we have boating and we have walking. So I'm going to label the walking X and the boating Y. And it doesn't matter which one you do. So together, the boating and the walking, the time they spend doing both of those has to be less than or equal to 48 hours because they have to go before the snowstorm. Oops, here. And then our speed, our miles that we have to go, we are doing 12 miles per hour on the boat. So that means 12 times y plus 3 miles per hour walking. So 3 times our x value. We have 240 miles. So they can go over 240 miles. They could also go exactly 240, but that's how far away their base camp is. So their boat and their walking could go more than 240, but they have to go, they could go exactly 240 as well. But they probably don't want to go over that since that's where their camp is at. All right, so now in order to graph these two, we have to solve both of them for y. So we're going to minus x on this one, and we're going to have y is less than or equal to 48 minus x. And I'm going to flip this around so it's in mx plus b form. So it's negative x plus 48. And then we're going to have to do the same thing with this equation. We're going to have to minus 3x from both sides. So we're going to have 12y is greater than or equal to 240 minus 3x. And then we're going to divide by 12. So y is greater than 240 divided by 12 would be 20. And then negative 3 over 12 would be negative 1/4 if I reduce that with an x. And again, I'm just going to flip this around so that it's in mx plus b form. So now we have to put these on a graph. And the first one here, y is less than or equal to negative x plus 48. Our y-intercept is 48, so that's going to be about there. And we're going to come down 1 and over 1. So because my graphs are going by tens, I'm going to come down 10 and over 10 because 10 over 10 is the same thing as 1. So if I come down 10, I'd be right here, and then I have to come over 10. So that's going to be about right here. And these are underlined graphs, so they're going to be solid lines. And then this one, our y-intercept is 20, so we're going to put a dot at 20. And our slope is negative 1/4. So I kind of want that bottom number to be a factor of 10. So I'm going to think about negative 1/4. I'm going to change it so it's got 20 as a denominator, so I'm timesing by 5. So I'm going to come down 5 and over 20. So I'm at 20, I'm going to come down to 15, and I'm going to go over 20. So I'd be right there. And again, this one's underlined, so we're going to use a solid line. Now as for the shading, y is greater, so we're above the green line. And then the red line, y is less than, so we're under the red line. So they overlap in this little region right here. So the time they spend on the boat is any ordered pair, and walking is any ordered pair in that area. So for instance, if I pick this dot right here, that ordered pair is 10, 25. So that means that X is our walking, so they would spend 10 hours walking and 25 hours on the boat. So there's all sorts of different combinations of points that fall into that shaded region, and they're all possibilities of the time that they spend getting to their camp. The last one we're going to look at has multiple inequalities to graph, and it says graph the system of inequalities and then classify the figure created by the solution region. I missed my end there. So the first one I'm going to do in blue, y is less than or equal to 5. So it's just a y and a 5, so that means on the y-axis there's going to be a dot at 5. And there's no x involved, so that means my slope is 0. So I am going to have this line all the way across, straight across here at 5. And it's underlined, so everything is underlined here. Oops. So I'm going to make this line. And y is less than, so less than is under. So all of this area, and I'm not going to shade too crazy yet because I have to graph everything else yet. Then we have y is greater than or equal to 2. So again, on the y-axis at 2, and there's no x involved, so our slope is 0. So straight across here at y is 2, and it's underlined, so another solid line. And y is greater than, so we're going to shade above that line. And then our next one is 3x plus 1, so y-intercept is a positive 1, and our slope is 3, so we're going to go up 3 and over 1, and up 3 over 1. And I can do that down 3 and back 1 as well. Back 1. And again, underlined inequality, so a solid line. Oops. And we have to change another color. Oh, no, I got to do my shading. Y is less than this, so that would be under this line. So we're going to go there. And then we have our last line. Y is greater than or equal to 3x minus 4. Our y-intercept is negative 4. And our slope is 3, so we're going to go up 3 over 1. I'm going to do that a couple more times. 2, 3 over 1. And then I'm going to, again, draw my line. It's underlined, so it's a solid line, not dotted. And y is greater than this, so we're going to shade on top of this purple. So we're looking for where all of the shading overlap. So every color has to be there. So we're under that blue line, we're above the green line, we're to the left of the purple line, and to the right of the red line. So right here in this little area is where our overlapped region is. So they want us to classify that. Well, it's a four-sided figure, so that's a quadrilateral. And if we look a little bit closer, the blue line and the green line are parallel because they're both straight across lines. And the red and the purple are also parallel because if you look, their slopes are the same. So